Okay, so question 9, they give you a stem and leaf diagram, and then this is they give you the key as well. 32 means 32 minutes, so this is 24, 25, etc., etc. Okay, and teacher expected the assignment to take 30 minutes. So find the percentage of students who took longer than expected. So you need to find the number of students who took more than 30 minutes, right? Which is from here onwards, honestly, and then down. So you count the number of entries, right? And then you should get about 31. Okay? Not 31, sorry, 11. Well, yeah, 11. Yes. So, A part 1, I'm just going to write my answers here. Number of students who took more than 30 minutes. And that's 11. And then percentage of students is just 11 over 20 times 100%. That is equals to 55%. Okay, and then find the median time. How do I find the position of the middle? Median is middle, right? So how do I find the position of the middle? I just take the total number, add to 1, and I divide by 2, right? That will give me my position. Okay, so in this case, let me find the middle student, right? So that will be position of median equals to 20 plus 1 over 2. I'll get 10.5, right? 10.5, let's count, okay? So I start from the fastest kid, which is 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I got 10.5, right? So I need to find this middle time here. So essentially, I'm taking the middle between 31 and 32. So median time, that's equals to 31 plus 32 over 2. I'll get 31.5 minutes. Don't forget your minutes, okay? Min. There's no S at the back. Explain why the mean may not be an appropriate average to summarize the times taken by these students. Okay, why is it not appropriate? So for that, we need to go back and look at this stem and leaf diagram. Can we see anything that makes it not appropriate? Actually have, right? There's this entry that this student took 69 minutes, whereas it's a very long time, right? And it's very unusual. So it might not be representative of the other students because maybe this student is just very, very slow and the other students are generally faster. All right, so maybe this is what that will skew this average and it's probably not appropriate. Okay, so you can just say the mean, right, may not be useful as there is an extreme value of 69 minutes, right? Which may not, which may, sorry, affect the mean of the data. Okay, and then you want to find the standard deviation of the times, right? 1 mark, very, very brutal. Okay, I'm gonna write it here. Okay, so standard deviation, how do I find it? It's actually what? My root of my variance, right? right? And variance, how do I find it actually? What is the formula for it? It's actually my sum of all my entries individually squared over number of entries minus sum of all my entries over number of entries, whole thing squared, right? So how do I find my sum of my entries first? It's just what? 24 plus 25. Basically, just add all of the students' times, right? That would give me 691. How about sum of all my entries individually squared? 24 square plus 25 square all the way until 69 square, right? This is a big number, 26239. Okay, then after that, I just put it back into this formula variance, right? 26239 over, and that's 20 minus 691 over 20, whole thing square. So my standard deviation is just 10.9. 3SF. Okay, part 5. Standard deviation of times taken by a second group of students is 8.64 minutes. Okay, so use this information to comment on the one difference between these two distributions. Okay, so what does it mean by my standard deviation being smaller than the other? It actually means that my readings are more consistent, right? Why? Because actually standard deviation, you're measuring the, what's that called? How far the points fluctuate from the mean, right? So if it fluctuates more, which is if I have a higher standard deviation, it means that my readings are less consistent, right? As compared to a standard deviation that's lower, my readings fluctuate less, and my readings are therefore more consistent, right? So putting that in words, I can just say that time taken by second group had more consistent results as they have a lower ST. ST meaning standard deviation. Okay. Okay, part B. Bag contains 9 white balls, 5 red balls, 2 black balls. 2 balls were taken from the bag without replacement. Draw a tree diagram to show the probabilities of the possible outcomes. Okay, so I know total I got 16 balls, 2 balls picked at random. Gotta draw a tree. Okay, let's go. So, tree diagram. This is my first ball. Right? I got 9 white balls. Probability of getting a white ball would be 9 out of 16. Sis. 9 out of 16. Right? This is my white ball. Right? Red ball is 5 out of 16. Blue ball be 2 out of 16. Okay? Not blue, black, sorry. Wait. What if I get a white ball again? This is my second ball. My probability will become 8 out of 15, right? And then red ball, that would be 5 out of 15. Black ball be 2 out of 15. Similarly, in the next round, what's my probability of getting a white ball after I got a red ball in the first try? 9 out of 15, right? How about 2 red balls? 4 out of 15. 1 red, 1 black. 2 out of 15. Okay, then you just same logic, just finish this tree diagram. Uh, 15, 1 out of 15, okay? So this is your tree diagram. Okay, so find as a fraction in its simplest form the probability that the two balls are the same color. So if they are white, white, red, red, black, black, right? So A, P, probability of two same color, right? So that will be 9 out of 16 times 8 out of 15, right? Because white, white. Plus 5 out of 16 times 4 out of 16. 4 out of 15, sorry. Cos red, red. Plus 2 out of 16 times 1 out of 15. Why? Because 2 blacks. Okay? It'll be 47 out of 1. Okay, if you need to have some visualization, let me just write it out for you. This will be probability of first white, second white, probability of first red, second red, probability of first black, second black. Okay, and then part B, at least one of the balls is white. Okay, so at least one of the balls is white. You realize that you're gonna be adding a lot of things if you try to find directly, right? So what if I just take the other way around, which is I minus from 1, right? Because total probability is 1. So if I take 1 minus none of the balls are white, right? That will give me at least one of the balls is white, right? So that is a much simpler route. Well, I mean, you can always find directly that if one of the balls is white, but there's going to be a lot of permutations and combinations that you'll be doing. So yeah, so P at least one white, right, equals to 1 minus P no white. What would that be? 1 minus no white. So what if I get two uh two red or 1 red blue, right? So that would be 5 out of 16 times 4 out of 15 plus 5 out of 16 times 2 out of 15. Okay, plus in the black branch, I get 2 out of 16 times 5 out of 15. But next one is 2 out of 16 times 1 out of 15. Okay, essentially, what branches am I looking at when I find this, when I do this question? This one, right? And this one, and this one, right here. Okay? These are the combinations. Okay, when I minus from 1. And then my total value is just 7 out of 40. And I should get final answer 33 out of 40. Okay. Yes, yes.